auxiliary view. A height auxiliary view is derived from the top of an object, will show true height. Let's use the letters to label all the visible surfaces in the given views and then use the line and the surface relationship to find out where they are in the front and the top views. After it, we are going to count the dimension so that we can draw the same size glass box in the isometric view. This object is 3 units wide, 3 units high, and 2 units deep.
After finishing the glass box, we are going to take a look at the normal surfaces. Because surface A is the surface right in front, so we can measure the width and the height to start the surface A in the isometric view. Once we finish the surface A, we can take a look at the surface connecting to the surface A, which is the surface C right on the top. Surface C is a normal surface parallel to the top of the glass box, so we can measure the width and the depth from the top view to draw the surface C in the isometric view. Once we finish the surface C, we are ready to draw the inclined surface B. Since surface B is inclined, it's better to label the corners by number so we can track these numbers in the isometric view. Make sure you can count the height, width, and the depth from the given two views to determine 1, 2, 3, 4 in the isometric. Once you have 1, 2, 3, 4 connected in a sequence order, you can see the inclined surface B in the isometric. After the surface B, we can continue to draw the normal surface D. D is a triangular shaped surface. After the surface D is completed, we have one more normal surface left. This surface, we can label it as a surface E. Surface E in the front view and the top view appear as vertical edges. At this moment, we can conclude the completion of the isometric view. Let's take a look at the glass box. The front plane and the auxiliary view plane are perpendicular to the top plane. So the lines measured from the front plane are the same lines transferred to the auxiliary view plane. The lines from the front view are measured from the top to the bottom, which is the height. So this is called the height auxiliary view. Let's take a look at the folding plane lines. The folding plane line between the top and the auxiliary view is a line parallel to the inclined surface edge. The folding plane line between the top and the front is an horizontal line. Because we want to measure the height from the front view, so the second folding plane line, we want to place it to the top of the front view. After the folding plane line, we're going to do the right angle projection from the numbers on the inclined surface edge from the top view. By following these construction lines, we can locate the numbers in the auxiliary view. Number 1 and number 3 on the folding plane line. Number 2 and number 4 are 2 units away from the number 1 and the number 3 vertically. Once we have 1, 2, 3, 4 located in the auxiliary view, we can have them connected in a sequence order. This is a true size inclined surface B in the auxiliary view. We call it a partial auxiliary view. After the partial auxiliary view, we can focus on the rest of the corner points, continue to do the right angle projection to locate the rest of the surfaces. For example, starting from this corner, we can continue to see the surface A. Surface A is an L-shaped surface. We can also use the numbers to track where is this surface located in the auxiliary view. We need the second corner to locate the complete shape of the surface A in the auxiliary view, since it is an L shape. If you take a look at the isometric view, you can see next to the surface A, there is a surface E. So starting from this corner, we can continue to do the right angle projection to finish the surface E in the auxiliary view. Remember, in the complete auxiliary view, you have to show all kinds of the lines. So from the last corner, we can do the right angle projection to see this hidden edge in the auxiliary view.